In this demonstration, we're going to practice assigning IPv6 addresses to network hosts. Specifically, we're going to assign IPv6 addresses to this Windows server system and a Windows workstation. If you take a look at the configuration of the server, you'll notice that I have one Ethernet interface installed, and that's the interface we're going to work with today. As you can see, an IPv6 address has been statically assigned. But this over here, where it says IPv6 enabled, basically means that IPv6 is loaded, but it's really not doing anything. So what we need to do is go in and manually configure it. Let's start by configuring IPv6 on the interface right here. I'll click this link, and we want to modify Ethernet. Right-click on it and go to Properties, and we'll go to IPv6. Select Properties again. Notice that it's configured to get an IPv6 address automatically, so let's change that. What we're going to do is statically assign it an IPv6 unique local address, which is really the equivalent of a private IP address in IPv4. Unique local IPv6 addresses always start with FC00, so that's what we'll begin with. Then we'll fill out the rest of the network address. Because this is a unique local network, we can actually do whatever we want. With unique local addresses, it's advised that they also be globally unique, but not required. This means, in theory, it's the only IP address used anywhere, including the internet. We're just going to make one up here. So let's enter FC00 : then 1234 : for the second quartet, 5678 : for the third quartet, and for the fourth quartet, we'll round out the network portion of our address. We'll do ABCD. We can put 2 colons in, followed by the host portion of the address, which is just 1. Remember, if we use 2 colons in a row, it basically says everything between here and here is a 0. So instead of typing out a long string of zeros, we're just going to do a double colon. That tells the system, hey, see these 2 colons? Just fill it in with a bunch of zeros. We need to fill in our subnet prefix length. By convention, IPv6 addresses use 64-bit subnet masks, so put 64 here. You can use longer ones if you want to, but the general convention is to use 64. We don't actually have a router on this network, but let's pretend I do, and it has the IPv6 address of FC00 : 1234 : 5678 : ABCD : 100. We also need to enter the IP address of the DNS server. I didn't tell you earlier, but this server is also our DNS server. It provides name resolution services for the clients on this private network segment. We're just going to use it as the DNS server address. So I'll copy and paste the same address down here under Preferred DNS Server. And then we'll click OK and then click Close. At this point, we've assigned a static IPv6 address to this network interface. Let's take a look at what this looks like in ipconfig. We'll open up a command prompt and we'll type ipconfig. So let's look at the network adapter. Here is the static IPv6 address we statically assigned. It's host number 1. Notice, however, that there is a second IPv6 address, a link local IPv6 address. You might be scratching your head and saying, why are there 2 IPv6 addresses assigned? Notice that this is a link local IPv6 address, while this, that we configured manually, was a unique local IPv6 address. A link local IPv6 address is required for all IPv6 addresses. If you enable the IPv6 protocol on any interface, you're automatically going to see at least one IPv6 address, even if you don't configure anything else. That'll be the link local address. Then, if you configure an IPv6 address or get one dynamically, you'll automatically have 2 IPv6 addresses. The link local IPv6 address is automatically assigned for you. It's used for IPv6 functions such as the neighbor discovery protocol. You don't have to do anything with it. You don't have to manage it. Let the IPv6 protocol stack take care of that for you. And instead, focus on the IPv6 up here that you're actually going to use for inter-network communications, because link local addresses are just what their name implies. They're only valid on the local subnet. They can't be routed between networks. Basically, they're used for inter-subnet communications between network devices. You assign an IPv6 address to a Windows workstation in pretty much the same way as you assign it to a Windows server. So go down here, right-click on our network icon, select Open Network and Sharing Center, select Ethernet, and then we need to access the properties right here, Internet Protocol version 6, and finally, Properties. So just as before, it's configured by default to automatically give an IPv6 address. Let's go ahead and statically assign one. As we talked about earlier, the IPv6 address that we're going to specify here has to be on the same subnet as the rest of our devices. Because we're using a unique local addressing scheme, we begin with FC00:. Then we have to provide the subnet address, which again must be the same as the inside interface of the router, 1234:5678:ABCD. We'll enter : again to specify that everything between here is zeros. We'll give it a host address of 2, and we'll use the default prefix subnet length of 64 bits. Once again, we'll enter our gateway, so I'll just copy and paste this in here and change the host at the end to 100. Now we have to configure the IP address of our DNS server. I'll paste this in once again and change the host at the end to a 1, which is my DNS server. Now hit OK and close out all of these. Let's go over here and open a command window. Let's look at our IP configuration using the ipconfig command. Here's our IPv6 address. We check it out and it looks like it's on the same subnet as the interface of our server, so we should be good to go there. We have a linked local IPv6 address that was automatically assigned for us. We have our IPv6 default gateway defined, and it's on the same subnet as our host address, so we should be good there. Now let's do an ipconfig/all. We should see that the IPv6 DNS server is also set to that same address, and it is. Let's switch over to our DNS server and look at our records there. Okay, we're now on our DNS server. We'll go to Tools and then DNS, and we'll expand these out. You'll notice that in addition to our A records, which is what we used with IPv4, we now have an AAAA, or Quad A record, which is used for IPv6 hosts in DNS. Also notice that a Quad A record was created for our workstation because it's a member on my Active Directory domain. As soon as I update its IP addressing information, the appropriate changes were made to the DNS server. Here's the IPv6 address that we created for it. You can manually add a Quad A host address as well. We'll go up here and select New Host. There's a workstation that's on my network. Let's create a new Quad A record for it. It's called Linux 1. The FQDN, or the fully qualified domain name, is linux1.corpnet.xyz. Its IPv6 address is FC00:1234:5678:ABCD:5. Select Add Host. Now we have a record for Linux 1. Let's go back to our CorpNet PC1 workstation. Let's practice using some IPv6 utilities. Just as with IPv4, you can use the ping utility with IPv6, but you have to tell it that you're using an IPv6 address because by default, ping wants to work with IPv4 addresses. To do this, we add a -6 option, and then we specify the IPv6 address that we want to ping. Let's try pinging the network interface of our DNS server. Ping -6 FC00:1234:5678:ABCD:1. We're getting a response via IPv6 from the DNS server. Let's clear the screen. You can also use the NSLOOKUP utility because remember, there were IPv6 host records created in our DNS server for the various hosts on this network. Let's try resolving the IPv6 address for our DNS server, which is CorpNet DHCP server. Let's type NSLOOKUP CorpNet DHCP. Press enter, and you can see that it resolves the IPv6 address along with the IPv4 address. That's it for this demonstration. In this demo, we practice working with IPv6 addressing. First, we set up IPv6 addresses on a Windows server. Then, we set up IPv6 addressing on a Windows workstation. Then, we use the ping and NSLOOKUP utilities to make sure that our IPv6 addressing scheme was working properly.